So today we're going to take what we did last week with the unit circle and combine it with the right triangle trig that we've done for the last month through September. All right, we're going to start with some notes. The sine theta is equivalent to the y coordinate. All right, cosine theta is equivalent to the x coordinate. All right, and then tangent theta is the y coordinate over the x coordinate. All right, the reason being is because it's the unit circle whose radius equals 1. As a result, the hypotenuse is equal to 1. So if the hypotenuse is 1, sine is defined as opposite over hypotenuse. Well, the hypotenuse is 1, so boom. As a result, the inverse is, so cosecant would be 1 over the y coordinate. Secant, which is the inverse of cosine, is x over y, is 1 over x. Sorry, I got ahead of myself. I would do the next one. And then cotangent is your x over your y. All right, now, here's what's going to help you remember the sign, S-I-G-N. All students take calculus. All right, and then we're going to look at the letters. That indicates where trig values are positive. So, for example, all means all trig functions, all of them are positive in the first quadrant. Students begins with an S. As a result, sine and cosecant, its inverse, are the only positive trig functions in the second quadrant. Third quadrant down here is take, which is tangent. Tangent and cotangent, its inverse, are the positive trig functions in the third quadrant. That is because the x and y are both negative. And the negative divided by a negative turns it into a positive. And then when we go back to the fourth quadrant, we got C. Cosine and secant are the positive trig functions in the fourth quadrant. Okay? Now, here's our goal. There it is in all of its glory, the unit circle, 16 values. Okay? Our goal is that you're able to find the values of the trig functions in these 16 locations. And you can certainly memorize it. I'm not taking you away from that. However, today we will analyze and promote patterned behavior. Okay? And what I mean by that is how things are related. And it starts in the first quadrant. All right? Pi over 6. The sine of pi over 6 is the y coordinate is 1/2. The cosine, which is the x coordinate, is root 3 over 2. Now, if we go up to pi over 3, notice they just reverse. So these reverse as well. So the sine becomes root 3 over 2, and the cosine is 1/2. Now, for pi over 4, the good thing is, because it comes from a 45, 45, 90 triangle, the x's and y's stay exactly the same. All right? So they're both going to be root 2 over 2, root 2 over 2. If you know those values, you can do everything else, because everything else is based on that. I'll show you what I mean. Okay? So the tangent is defined as the y over x. To find the value of a tangent, we will place the coordinates on top of each other and use simplifying rational expression techniques to simplify and reduce. If necessary, we will then rationalize denominators. We don't always have to, but we will in some cases. All right, so tangent, as you can see up top, is y over x. And we just realized the y coordinate is 1/2, and the x coordinate is root 3 over 2. Well, if you don't remember this from last year in Algebra 2 with rational expressions, the 2's are going to cancel. We got 1 over root 3. Well, we need to rationalize the denominator. And we end up with root 3 over 3. Now, if you don't want to undergo that every time, you just have to realize the tangent of an angle whose denominator is 6 is going to be root 3 over 3. Okay? Now, pi over 3, they reverse. So now it's root 3 over 2 over 1/2. 2's still cancel. And now I got root 3 over 1, which is just root 3. All right? And the last one, tangent of pi over 4, and anything that has a denominator of 4. Tangent theta equals root 2 over 2 divided by root 2 over 2. Well, you'll notice numerator and denominator are exactly the same. So the tangent of anything that has a denominator of 4 is 1. Now, all right, last part of the process is the inverses. Since cotangent, secant, and cosecants are inverse of the other ones, we just need to find the reciprocal, all right, of each one to find the values. For example, 1/2 showed up for either sine or cosine. Well, the inverse of 1/2 is just 1 over 2. It's just 2 over 1, which is just 2. Root 3 over 2 showed up as sine over cosine. So that flips to 2 over root 3. And now we're back to rationalizing denominators. So now we have root 3 over root 3. All right. Which gives us 2 root 3 over 3. All right, we had root 2 over 2 for the pi over 4 family. Well, the inverse of root 2 over 2 is 2 over root 2. And if we multiply top and bottom by root 2, we realize that the 2's are going to cancel out. We just have root 2. And hopefully you realize the inverse of 1 is just 1. The other one we had was root 3, or root 3 over 3. And when we do the inverse of that, we end up with 3 root 3 over 3. The 3's cancel out, and I end up with root 3. So those are all your inverses. All right. So here's your unit circle. Here's everything. And here's the idea behind it. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. The magnitude or absolute value of their coordinates is always the same. They always have an x of root 3 over 2. They always have a y of 1/2. The difference is, over here they're positive, over here they're both negative. Here the x is negative, there the y is negative. So everything with a 6 has this same absolute value for the coordinates. Same thing with the 4's. Root 2 over 2, negative root 2 over 2, and root 2 over 2. Negative root 2, they all have the same. And the pi over 3's, they're all the same. So basically what you're doing, and if you realize that these are just flips of each other, really you're just getting two numbers. So here's what I mean. The sine of pi over 6 is 1/2. Well, guess what? These are all going to be 1/2 as well. Okay? The difference is down here, the y is negative. So now it's negative 1/2. The cosine was root 3 over 2. Well, these are also going to be root 3 over 2. All right? The difference is these are in the second and third quadrants. In the second and third quadrants, x is negative, so the cosine is negative. The tangent ended up being root 3 over 3. Okay? Well, guess what these all are? Root 3 over 3. All right? But here, both in the second and fourth quadrant, they are negative. All right? So the values are the same. Anything in the sixth family, the values are the same. It's just a sign, SIGN. Now, cotangent is just the flips of the tangents. Well, we realize using inverse is that that's just root 3. All right? And then if tangent's negative, the cotangent's also negative. So they're both negative in the same quadrant. Secant is just the flip of cosine. All right, so if we flip root 3 over 2, we go through the process we did before, which is 2 over root 3. And then when we rationalize the denominators, we end up with 2 root 3 over 3. Well, guess what? Secant for all those is 2 root 3 over 3. Secant is negative where cosine is negative. So if cosine's negative in the second and third, secant is negative in the second and third. And cosecant is the flip of the inverse of sine. So the cosecant for all of those has a magnitude or absolute value of 2, but cosecant is negative where sine is negative. So they all end up being negative 2. Pi over 3 and pi over 6, the coordinates just flip. So all these are the root 3 over 2, and all those are the 1/2. The tangent is the root 3 over the 1, which is just root 3, which means the cotangent becomes the root 3 over 3. Secant is the flip of cosine, so now that's the 2. Cosecant is the flip of the sine, so now that's 2 root 3 over 3. All right? But when we come here, it's positive, negative, negative. Here, negative, negative, positive. Here, negative, positive, negative. Negative, positive, negative. Negative, negative, positive. Positive, negative, negative. So the values are the same, but those are how the sign switches. Now, the pi over 4 family, we're looking at root 2 over 2 and root 2 over 2. Tangent and cotangent are 1 from the previous section. Secant's the inverse, so we end up with just root 2 when we invert it, as shown before earlier in the video. All right, same idea, positive, negative, negative. Negative, negative, positive. Notice the same as above. Negative, positive, negative. Negative, positive, negative. Negative, negative, positive. Positive, negative, negative. So if you know those facts, if you know where it's positive and negative, and you literally know this, you can do everything else. Now, is being able to know what they rationalize to going to help? Absolutely. Is tangent simplifying to going to help you? Sure. All right, but it's not necessary if you know those values. That's it. All right, now the last one is the specials. Okay? So, coordinates here at 0 or 2 pi is 1, 0. Now remember, cosine is the value of the y, the x, and sine is the value of the y, so they're 1 and 0. Okay? Tangent is sine divided by cosine. Well, that's 0, because 0 divided by 1 is 0. All right, cotangent would be 1 divided by 0. Hopefully you realize that does not exist. So, the cotangent for 2 pi or 0 does not exist. The secant is the inverse of cosine, so that's 1 as well. And the cosecant, which is the inverse of sine, would be 1 over 0, so that does not exist as well. You're going to find for all these the angles found on the axes. So there's 1, 0, there's 0, 1, there's negative 1, 0, and there's 0, negative 1. That's going to be the case for all those. I'll show you what I mean. If we go to pi over 2, now the sine is 1 and the cosine is 0. So the tangent is the 1 divided by 0. So now that does not exist because we can't divide by 0. Cotangent, though, is cosine divided by sine, or x divided by y, so that's 0. The secant is 1 over the cosine. Well, 1 over 0 we just went through does not exist. Cosecant is the inverse of 1. Notice, a pair of 1s, a pair of 0s, a pair does not exist. Pi and 2 pi are related. The only difference is now the x-coordinate is negative. So instead of 1, that's now negative 1, and same with that. 0 you don't negate, so those are both 0. And guess what? If it did not exist in the positive, it does not exist in the negative. And then 3 pi over 2 is just like pi over 2, but the y is negative. All right. So those values are negative. Tonight's homework, all you're doing, okay, all you're doing is going around it. So in other words, in tonight's homework, it's posted in Google Classroom, but you need to show tomorrow, unless you're virtual, sine theta, and this is how you should do it. Anything that ends in a 6, the y-coordinate is 1/2, so I know the number part is 1/2. You have to remember, well, sine down here, well, tangent is the only one that's positive, so that's going to be negative. Okay, cotangent, it's the 4 family. Anything that was cotangent in the 4 family, the cotangent was 1. Okay, this is, what is it, positive or negative? Well, over here, the y and the x are both positive, or both negative, and a negative divided by a negative is positive. Finally, over here, the secant of pi over 3. Well, the secant is just the inverse of cosine. The cosine is 1/2. The inverse of 1/2 is 2. Secant's positive, so boom. So that's what you do in those. It may seem easy, but we're getting you to understand what it is. And then the last 10, the only difference is there's no diagrams. All right, so hopefully that was clear enough. If not, message me with any questions and have yourself a fabulous day. B's, we'll see you tomorrow with it. A's, if you didn't show it to me in class, you can post it here in Google Classroom tonight. Stay healthy.